In this video, we're going to be looking at graphing a linear function given an equation. But before we get to the graphing from equations, let's talk about graphing in general. There are two ways to graph a linear function. I can do it using 2 points, or I can graph the linear function using a point and a slope. Let's start by looking at the example of 2 points. So example 1 tells us to graph a line passing through the points 2, -1, and 4, 2. The idea here is to plot each point, so 2, -1, and 4, 2, and then draw the line connecting them. So when I plot these points, the first number, 2, is the x-coordinate. So I would go to 2 on the x-axis, and then -1 on the y-axis, and I would leave that point right there. 4, 2 means to go to 4 on the x-axis and 2 on the y-axis, which looks like that. And you can see the computer has already drawn the line for me that would connect them. So I've produced this graph. If you were doing this with a pencil, you would draw each point and then take a ruler and draw a nice straight line right through them. That is pretty basic. Nothing there that you haven't seen before. The next example that we'll see is, again, should be pretty familiar to you, but does involve a little more thought and a little more carefulness. Now let's graph the line passing through the point -1, 2 with a slope of 2/3. Well, I can plot the point -1, 2 in a fairly straightforward manner, but when it comes to using that slope, that probably bears a little discussion. So let's look at what slope means. Slope, which we represent with m, is equal to the change in y over the change in x. So from one point to another, the slope tells us how much each of those coordinates is going to change. So in our case, that slope is 2/3. So what that tells me I can do is that when I make my second point, I start from my first point, -1, 2, and I'm going to increase the x value by 3. So I would go 1, 2, 3 over. Now I'm going to increase the y value by 2. Up 1, up 2. And that gives me a second point. And when I look at these points, the x value of my first one is -1. The x value of my second one is 2. Well, -1 plus 3 is 2. When I look at my y values, I started at 2 and ended at 4. If I take 2, add my 2 to that, I then get 4. So our slope is telling how much the y changes and how much the x changes when I go from one point to the next. If my slope is a whole number, like 3 or 4 or 5, I can think of that as being 3/1 or 4/1. So if it is not a fraction, I can put a 1 in the bottom to indicate that my change in x would just be 1. Now in middle school, you probably learned this as rise over run, which is a perfectly reasonable way to think about this. From our original point, we rose 2 and ran 3. Now we are ready to look at graphing from an equation. So in example 3, we have the equation y equals -4x plus 3. This is an equation in slope-intercept form, y equals mx plus b. And so we know what two things we can find from this. We know that first we can find our slope just by looking up at the equation. It must be -4. We can also find b, our y-intercept, is going to be 3. So from this, I can now go plot my y-intercept. Plot just means to put a point down on a graph. And I'm going to put that at 3 on the y-axis. I then know I have a slope of -4, and remembering that when it's just a number I can make that -4 over 1. So my x changes by 1 and my y changes by -4. So I would go over 1, down 4, and that gives me a second point which I can then connect, and now I have graphed my line. Since we've done this now for slope-intercept form, there's no reason we can't do it for point-slope form as well. So from point-slope form, we can find two pieces of key information. We can find our slope, which is going to be what's right in front of the parentheses, so in this case 2, and I can also find a point, and for this I have to be very careful. I need to take the opposite of what is with the x value, so in this case +1, easy for me to say, no? And then the opposite of what is with the y value, so in this case -3. And notice that now I have the same situation I was in before, where I have a point and I have a slope, which means I have everything I need for the line. So the point that I want to graph first is 1, -3, and my slope is 2, which I can change to 2 over 1, which means I'm going to have my y value change by 2, my x value change by 1. This now gives me a second point, and I can graph the line. Finally, we can look at graphing in standard form, which is, I'd say, the most complicated of them in that nothing is given to you very simply. You kind of have to go find it for yourself. And remember, there are three things we can find. We can find our slope, which is going to be the opposite of a over b. We can find our y-intercept, which is going to be c over b. And we can find our x-intercept, which is going to be c over a. Now, in order to do all of this, I have to know what a, b, and c are. A is the coefficient of x, so 3. B is the coefficient of y, -2, and c is the number all by itself on one side of the equation. So now I'm fully equipped to find everything I need. The question is, what do I need? And so it depends on your preference. If you feel very, very comfortable with finding a point and a slope and graphing from there, like we've done in the last two examples, you can find either the x or the y-intercept, plot that point, find the slope, and use the slope to find a new point. Or, since we can do this using 2 points, I can find the x and y intercepts and use those. I prefer that method because graphing from the 2 points presents less opportunity for mistakes. So let's go ahead and calculate those x and y intercepts. The y-intercept would be 6 over -2, which is -3, and the x-intercept would be 6 over 3, which is 2. So all that's left now is to plot those 2 points. So the y-intercept is -3, so I would go to -3 on the y-axis. The x-intercept is 2, and when I connect those, I have made my line.